So today we'll be talking about functions. Before then, I wanted to talk about um, I remembered something I was supposed to discuss. I think on dictionaries, and I don't know if you attended any of the sessions, but uh, we were talking about dictionaries. Just give me a moment. And we did some couple of things in dictionaries, and let me see if I can run the okay. So we have a dictionary that has names as well as state, age, class. And so I wanted to mention this. If I say C dot keys and I see it and I run it, I think it's a method. Yeah, with keys. The method, and if I save it and run it, I'm going to see the keys of each and every um so a dictionary is a key value pair, right? If you read about dictionaries, it's a key value pair. You have a key and you have a byte value. So if I say a dictionary dot the keys, I call a method called keys. It's going to give me all the keys in that particular dictionary. And if I see and I want to print the values, I'll just say dot values, and it's a method too as well. It's going to print all the values in my dictionary. So these are my values, and it prints them as a list. And we have the values for name, values for date, values for um, age, and values for car. I just remembered and I wanted to mention that. So um, we're going to functions today. A function is like what functions help you to do. It helps you to do two things. It would help you to hide um your script. A function um it helps you hide your scripts, and the second thing is that it helps you a lot in writing so many usability to or reusing. When you write a Python script, you can actually reuse it if you build it in a function. So let me give you an instance. So if I say a assigned variable a is 3 and b is 2 or 4, and I want to do a different kind of mathematical operations on this. I'll say a plus b. Sorry about that. A minus b, a divided by b, and the last one will be a times b. Now, for every time I do this and I run my script, you can see the different values. A plus b is 7, that's 3 plus 4 is 7, a minus b is negative 1, a divided by b is 0.75, and a multiplied by b is what? 12. So 3 multiplied by 4 is 12, 3 divided by 4 is 0.75, and so on. Now, a function can help me make me reuse this particular um reuse this particular or redo this particular operations if I'll just write the function just one time, and I can use it over and over again. So you if you want to write a function in in Python, you start by using def, which is function, and then you give it a name. So you have like a function name. So you write a function by saying function, then function name, then you have an attribute, then have your hyphen, then any other thing you want to write, it has to be a child of this function. So if you, and Python is an indentation language. So if you want to make something a child of what comes before, you just give a tab or an indent, and it just shows that this, whatever I'm going to write here, belongs to the script or the code before it. So you can then write your instruction here, and it does whatever it is you want to do for you. And the good thing with functions is that you can actually reuse it. So I said you start by saying def, so then you give it a function name. So let's say I want to do math operations. I can say math underscore ops, and I'm good. Now whatever I'm going to enter inside this particular bracket is what they call attribute of this particular function called math op. So what I want to do is do math operation on two different variables, right? So I can see a comma then b. Those are my variables, and they are attributes of this math ops function. Now, so I can say just print a multiplied by b, right? And so by the time I'm done defining my function, then if I then want to start using this function, what I'll just do, I'll just say math op. That's the name of the function. I'll call the name of the function math ops. Then the attribute is what I'll start entering. So I'll say maybe 4, 6. And when I save it, what is it going to do? It's going to print whatever I represented as. So this 4 is assumed that it is the first attribute here, which is a. Then this b, the b is the 6 is the second attribute. If I want, I would just say b equal to 4 and a equal to 6, right? And save it. And so I'm now saying that, oh, whatever the value of b is, the value of b now is 4. Now once I run my Python function, so you would see b is let's just print something. So I will see I can see I'll put a f, print f. I would say the multiplication, let's just say the subtraction of a or b from a rather. I'll then see is, I think I'll just copy this or cut it and just do something like this. I'll say a minus b and save it. And so by the time I run this function again, you can see that the subtraction of 4 from 6, it's supposed to be 6 from 4, actually is actually 2. So I'm saying that b is 4 and a is actually 6. If I then say let a equal to 4 and b equal to 6, I'll get what? -2. So it's -2. Now if I don't feel like it, I'm just going to do this, and so it is going to assume that the default value for a is actually 4. So it's same thing as this. But so this is by default, unless if I go and specify them that no, I want B to be this and A to be something else. You get? And then I just need to call the function, enter my variable or attributes, and you can see it's basically the same thing. So I could write a function inside another function. So I can write a function inside another function. Why is that? Why should I do that? So let's say the math operation I want to do are multiple math operation, in the sense that I want to do for so different math operations, for instance. So what I can then do is to say let's see, I can leave this particular place empty, then I would go to the next place and the definition, I would see subtraction, or just say subtract, and enter. Or I could actually leave this as A, comma B, and I'll just say subtract, and leave this empty. Then I would say print I'll say print A minus B. Then if I let me do for different operations, so it will be this subtract, this is addition, so I'll just say add. I'll say print A plus B, divide. If I want, I'll say A divided by B, and the last one will be multiply, and I'll just say A multiplied by B, and multiplication is asterisk. Now for my math operation, when I'm done writing, I'm going to save, and then funny story, I can declare an instance of this math operation. So what I can just say is I can declare an instance of it. How do I declare an instance? I'll give it a variable. So I'll just say A is equal to math underscore ops. Then I will then declare any variable. I can just say 10, 11, for instance. Nothing happens, because even if I run this, it doesn't do anything. How then do I want to start doing something? If I want to do any kind of math operations here, what I will just do, I'll just say A dot, I'll now say subtract. Subtract, that's the name of my function, and I'll just call it as a it will look like a method, but in reality it's a function. So when I run it now, what am I going to get? I'm going to get negative 1. Okay, sorry, is this subtract I wrote? Oh, sorry about that. Why am I getting error? Let me see. Oh, apologies. Apologies. I see what the issue is. I am mistaking this for a class. Apologies for that. So if I declare the instance and I enter my variable, sorry, excuse me, onto sneeze. So many apologies. What I can then do is to say I'm going to put this inside um, a square bracket, and I'll just say subtract, and I'm going to save it. If I then run it, okay, oh, I'm supposed to use oh, I think the reason why this is not working is I'm supposed to return all of this. Sorry. So I'll just say return um, subtract. I think so. I'm supposed to return all of this, which is why it is not showing. So add divide. So I think that's the reason why it is not showing the multiply. And then I think if I then do this, interesting. Why is it returning an error for me? One of the most interesting things I've had to deal with today. Oh, I think I'm supposed to return this in a dictionary. Okay, and I think I can return it. If I'm going to use a dictionary, I think I can return it one time. So I'm supposed to return a key value pair, subtract. Oh, yeah, subtract, and I will just do this, and I think I'll do add. I'll also return add. Also, I can then call them like so divide. I'll do divide, then multiply, then I'll do multiply. Let me save it and I'll call it like that again. Okay, oh, what mistake did I do? Oh, so this is supposed to be hyphen and save. Also, then I will get so basically what I'm going to do is if I call it like this, I'm going to get -1 because 10 minus 11 is -1. And I can do for multiply, for add, divide, and multiply, I think. Yep. And if I save it, I'm going to get the different values. Let me just print, I'll just say print different operations, mathematical operations, I think. Mathematical operations. And then if I run it, I'm going to get -1. That is for division, 21 for addition, and this is no, this is subtract, divide, and subtract, addition, divide, and multiplication. And if I want to make this stand out, what I can then do is just to say this is subtract, right? Subtraction, and I'll just do something like this. So I can just get an idea of what operations is happening. This will be addition, This will be division. Then the last one will be multiplication. Then when I save it, I run the program again, and I'll get subtraction, this, addition, just so that I can tell what particular program is actually running at that particular point in time. So you can actually declare a function inside another function. When you are done declaring these functions, and whatever it is they are doing, the operations they are doing, then you have to return them as well. I forgot to return them, and I can choose to return them in a dictionary. And so because this is a key value pair, this is a key and this is the value, if I want to call it, I'll just put a square bracket and call the name of the key, and it will just give me whatever the value is. And the value for subtract is a minus b, which is in this case 10 minus 11. And if I say if b equal to 10, a equal to 11, I'm going to get very different response. Oh, what did I do? Oh, subtract. I think I did something. And so you can see subtraction is 1 because 11 minus 10 is 1. Addition is 21 still. 11 divided by 10 is 1.1, and still multiplication. So it changes depending on whatever it is you are actually the variable you declare as what, depending on how you do it. So this is just an introduction to functions. I don't know, did you get the message I sent over for the link? I sent over a link, I don't know if you saw it.
It's to the group, right?
Yeah.
I've not checked that.
Interesting. Okay. And so you can actually use okay.
The link I'm seeing here is just the link for the class, the Google link.
Okay, I think I'll share it again. I'll share the link for you guys to actually check it out. It's W3 Schools. I don't know if you know that website.
Yes, I need W.
So they have very good yeah, materials are quite good currently.
Okay.
The materials are very, very good. Very good. Anyway, in terms of the kind of attributes you can actually declare in a function, this is what they call what's the name of these attributes? Well, these are arguments per se. Or I call them arguments. There are different methods to argument you can actually do here. So there is this another one where you can actually declare something and then do whatever it is you want to do. You can declare as many as you want, then do whatever it is you want to do. But there's another method to this. There is let me see. I'm going to, I think I should use Anaconda for this purpose.
Sorry, sir. I have a question, sir.
Yes, please ask.
Okay, sir. So in this function we created, so and we try to return this so, subtract, add, and then division. Do we still need to put the key and the value? What is the purpose of the key and the value we put at the front of the return?
Okay, so I could just do sorry, just hold on. Let me open this one up. Let me answer. Hold on, please. I want to lab or notebook. Okay, I think it's lab. When do I want to download this? Remind me later. Sorry, please hold on. Just give me a moment.
All right.
Oh, so when I say I want to instantiate, I'm just declaring a variable to be that particular function, then I'm adding new values to the argument. So that's called instantiation. And so for this, I'm going to instantiate them by declaring for every function that exists here an instance of it. So I can say a comma b comma c comma d, for instance, is equal to math up. Then I will say 12 comma 10. And so nothing had okay, sorry. I keep using subtract. Sorry about that. So nothing happens now. If I want to just do subtract, I can just say a, and I'm just going to so again you can put in the difference between the use of VS Code and Anaconda is that I don't need to use print. So if I say a, it means I mean subtract. That will be the first. So this a is I'm declaring the first function, instantiating the first function of this particular math operation, which is subtract. B will represent add, C will represent divide, and D will represent multiply. And so if I say A, run it is going to say subtraction is equal to 10. If I say D, instantiate it is going to say 200. Now let's do something. Let's do something. So I said subtract. I'm going to return subtract, add, divide, and multiply in the order to which I wrote the functions, right? So, but let me do this. I want to multiply to be first. Confirm settlement and like that. Now, if I instantiate this particular math operation function, if I say A will give me multiplication. So the order to which I instantiate this particular these variables to this math operation is in the order to which I'm returning them. You understand? Not to the order to which I wrote the function. Does that make sense? So you can use this method if you want, and so this method will guarantee that by the time I instantiate, I say or anything is equal to, you know what, let me do this math operation 1, and I will say something like this, and I say int is equal to math up, then I will declare maybe a equal to 70, b equal to 40, for instance, and then if I say int so if I'm using this kind of method, the key value pair method, as the dictionary, you know, with this, I'm just returning them, I'm not doing key value. So if I want to instantiate, I just say A, then I'll say A, B, C, D, then I'll instantiate it, then if I'm calling them, I'll do this. Now, for this other part, just call them. So instead of just doing like this, I'll just declare what I want to, which of the functions do I want to use? If I want to use add function, I'll just declare it like this. And what is it? Writing down that is wrong. I think I need to write it again. I think it's one of the problems with the use of anaconda. Let's see. Yeah. Oh, so you can. Okay, so this is one of the problems I have with anaconda sometimes. So you can see when I click on add, using the key add that represent add the value, which is this addition here, it returns addition. So you can either do a key value pair, or you could just call them like this. But you can see the advantage or disadvantage of this. For me to do any instance, if I want to declare this argument, I will have to call each. I will have to use a variable to represent each and every thing I'm returning here. So if I say multiply, just return multiply and divide. If I do this, I'm going to get an error. Why? I'm only returning only two functions. So what I'll just do is just to remove it. And so it's going to declare A is equal to this multiply function, and then B equal to the subtract function. And if I say divide, it's going to do it in that particular order. And so if I instantiate A, it will see multiply because that's what I did. If I do B, I'll see right. If I want, I can see add, and it's going to, these two instances will be add and divide based on how I'm returning them. So you can see add, then divide. If I want, I can say subtract, depending on what I want to do at that particular point in time. Oh, it's actually writing subtract. Sorry about that. I don't know. Subtract. Is it subtract or subtract? I think it's subtract.
Subtract.
Yeah. So I think it's my mistake. Let me pause this. Sorry. So subtract. So depending on what you want to actually do.
So yes, but sorry, sir. What, since it's a function and a function make our code more easier to execute, what if it's in a case whereby we have different value for our A and B? For instance, now if I'm to multiply 1 times 2, and at the same time I'm not multiplying again, I want to do addition but with different value, did I need to come back again to be putting different value in the instance of the initialization of the A and B?
Yes, yes, you have to do that every time. So let's do AB. I can just, so if I want to do something else, I'll just come here, do this, and just change the values. Basically, this is why they call it it's reusable, right? And I'm going to get a different result. If I do B, I'll get a different result. Does that make sense?
Yes.
So, but the idea behind the function is that you can reuse the code again.
Okay, but is it a must we need to put the argument value in front of the initialization?
No.
Just call it direct from the subscription or subscribe or whatever it is.
Sorry, I don't follow.
Yeah, can you hear me now?
Or is it that you need to do this?
Yes, must we put it there since it's a initialization?
No, you have to, because it is oh, I don't think so. If you want, sorry, hold on, I don't think so. You can do like this. Oh, it requires, you have to.
What if this the argument is now being put inside the function? Inside the function, yes.
Yeah. So you can call this, because this is empty. So look at what you are saying. Depending on where you declare it from, right? And don't have anything, right? So if I do this, but you can see the problem with this
You have to repeat the
repetition.
Okay.
And I don't want to have to do, but I can declare this instance like this and it works. So I can then say I'll say 400, 10, and it will do the subtraction for me. You understand?
Yes.
B, I can say 780, I see what you are trying to say. I see what
in case we have
I see what you are trying to you can actually do, but in repetition.
Because since it's a function.
Yeah, this gives you more control.
Exactly.
I see what
and then another question, sir. So what is the difference between return and this print in this our function?
Okay, so usually if you want to print, you return things like, you can also use return here. So look at, I can say return, let me show you the difference. Yeah, I think I struggled with this for a very long time. So I can return this, right? And let's say I'm going to return add and multiply. Do you get?
Yes, sir.
And I now declare instantiated. The first one will work. The second one, guess what's going to happen? Right? So, sorry, I'm supposed to say return. Hold on. Let me do return. Oh, it will still work. Oh. But let me do something. I want to do something. To return the multiplication.
Multiplication.
Multiplication, then I'll say this, then I'll do this and paste this and run it. If I run again. Oh, so the reason why this is working is because I think it is Anaconda, but let me check it.
No, I think it's because we initialize it. That's why it works, because automatically it will assign those.
No. I'm actually supposed to use a print for this. I'm supposed to use a print for this, but I think it's because I'm using Anaconda. Can you see the difference? Did you see the difference?
I have not spotted the difference. Sir.
Let me show you. Let me show you the difference. The reason why it is showing is because it's Anaconda that I'm using. Or digital notebook. You can see the difference.
Okay, this one returns in terms of string.
It will return a string, but look at this is supposed to return something like this. So you can see the difference between the print and return.
Okay.
So let me copy this. I'll copy it here. I'll take it to Jupyter. I would. How do I do?
Maybe you should put all this one in a comment.
Yeah, I'll comment. Oh, yeah, I think I should comment everything here. So if you want to comment, you can highlight everything and do Control / and it's going to comment. Now, what I'm then going to do is
Control what, sir? Control what, sir?
Control /
Okay.
So let me say B is math of 1, right? Then I would say I'll say 780, 10. I'll say B is 20, 4. So I save it, I delete this stuff, I run it. So you can see that this only shows me addition. Does that make sense?
Yes, sir.
So the reason why it showed me in the first place is because I'm in it. So if I do use return, I'm supposed to say print. Save it. So you can see the difference between print and return. If I use return, it will work but not return anything. but I'll have to print it again for it to show me. The reason why it showed me here is because I'm using Jupyter Lab, and which is why it showed me in like a text. Does that make sense?
Yes, sir.
So that's just the difference between. So return works as print, but it will not. It will not. You are just saying return this. If you want to view, it will do the work, but it will not show you. If you want to print, if you want it to show, you use print, but you don't have to do that every time. It's not everything you print. You just want to return, especially if you are dealing with if you are dealing with automation, if you are dealing with web development, you use a lot of return than print, because you want to return it somewhere. You don't want to print it out while doing it. You don't want to print out. So when you are doing printing, usually you are printing it out in the background. Just how do I explain it? Print usually is just for this particular purpose. If you are taking it for production, you don't use a lot of use it. You get, if you are doing machine learning and so, you don't do print, you do a lot of but the difference between return and print, you can see that return will do the work, but it's not going to display. But print is going to display it. And for now, we are all about displaying stuff. We are not interested in return for now. But during production, I think you use a lot of return, if I remember correctly. So that's just the difference. Like I said, why it showed me is because I'm using Jupyter Lab. It is going to return it. But ordinarily, I know for a fact that return does not display anything unless I say print and do that. Does that make sense? What other question? Hello, are you there?
Yeah, I'm good for now. I'm good.
Okay, good. Okay, so I wanted to talk about the different kinds of arguments you can actually use.
Okay.
So this is the first type where you declare as many as you want and ask it to do something for you. Now there is what they call what's the name? Arbitrary argument. You know what arbitrary means? Arbitrary means. You know what arbitrary means?
Not at all, sir.
That is not there. You are using something that is not there, like virtual. So
That is not virtual.
something that is virtual, something that is really not there in person. So that's what we call arbitrary argument. Now, you declare arbitrary argument by using an asterisk, then you call the argument anything you want to do. Let's say B or so. Now, I will do something. I'll say diff. I'll say add, and instead of me declaring addition between two
Arguments.
I will just say asterisk and A. What does that mean? What it means is that I can return A, sorry, I think it's A1 for instance. So I can return A, then I'll just say A1 plus A2 plus A3. If I run it, nothing happens. But if I want to then do an instantiation of this thing, I'll say let B equal add, then I'll say, because I now have three arguments, right? But
yes,
I now have three arguments, but I'm only seeing one based on the argument I displayed there. But by using that asterisk, you can declare as much argument as you want to. So let's say 2, 3, 7. Sorry about that. Why am I getting an error again? is saying that tuple. I think I'm supposed to say let's see. I think I'll just use the print. Let's see. Sorry about that. I see. I know the reason why this gave me an error. So I'm going to declare B equal this, then I'll return B. No problem now. So I'll instantiate. Why is this thing giving me an error? This is weird. Why is it giving me an error? It is not supposed to give me an error. It is not supposed to give me an error. I wonder why it is giving me an error. What am I doing wrong? I'm doing something wrong. Sorry, let me check. Why is this thing giving me an error? It's not supposed to. It really isn't supposed to give me an error. I'm wondering why. I'm overthinking this stuff, but let me see. Let me see what is wrong here. Okay. Actually, do I need to instantiate? Yeah. Oh, sorry. Forgotten an account that has its own issues. Let me do discipline and let's see what's going to happen. So what is happening here again? Mark up. Oh, don't worry about this. I think I'll say this and run also again. Sorry about that, please. I'm just trying to figure out what is the issue. Okay. Giving me error, returning error. Okay. I want to do this addition like this, but I think I can do something like this too as well. I'll just say return the sum of, actually I can use sum and A. It works, and if I say add A, it's going to give me 8, so apologies. I'm trying to implement something different from this. Oh, sorry for that. That was my mistake. Sorry for that. That's my mistake. I am not actually supposed to. I think if I want to do addition, I can use some of these and or I can actually say B equal. Sorry, I can say B is equal to plus equal to A. Sorry about that. And I'll return B. Then if I do add, okay, so B is a local value, cannot be accessed locally where it is not stored in value. Oh, sorry. I will not have the B equal to 0. Sorry. So I can't do.
What if we declare the B as a global variable?
No, it's still not going to work, and that's because it is the arbitrary argument is reading as a tuple.
Okay.
The reason why that is it's reading as a tuple, and once it does that, the arbitrary argument is reading as a tuple not be accessed locally. Yeah, so it does that. It's reading as a tuple, and so I'm going to do things that I only do to tuples, and this will not work basically. And so what I'm just supposed to do is, since I want to do addition, I can just say sum. Just say this is just the right thing to do. So no matter how many value I had here is going to give me a number. So this is the advantages of using arbitrary arguments. So I can add as much as I want, the as much arguments as I want, being that I've already told you to do something for me. Actually, I'm supposed to say print because ordinarily this will not work. This return will not work. I'm supposed to actually say print because if I do it, say here, copy and paste in. I'm just going to put. Okay, it's fine. It's fine. I'll do this, and I'll say. Sorry about that. Many apologies. It's been a while I looked at the basics of Python. I think I still need to look at it again. Maybe I know. So the this particular addition doesn't show, and that's because I'm supposed to use a print and do this. Save it, and if I then run it, you see the value. So again, just a reminder of the return and print. So the arbitrary argument. Let me give you an example. Let's say I want to declare a function called name, and let's say full name, and so I can just say name is fine. I'll just say names. Then I'll say print. I can do printf, and I'll just say hello. Then I'll say names. Right. The F string. Oh, I'm supposed to end it with this. Sorry about that. So now that I'm done, if I want to then declare an instance, I will just say, okay, so I'll say names, and I'll just say give me the print the third argument for this. Sorry, I'm not supposed to. Oh, print the third argument for this, and just say hello plus this person. So I'll say name, and then I'll say let me see your name. Taiwo Taiwo Shakil. Then I would enter. I think there is that. I think it's that video. There's another name. Oh, sorry about this. There's another name. I'll just enter the other name. I think this person attended the session yesterday. Now, once I run this particular instance, what do you think it's going to show? Can you guess? My network just went off. Let me see if I can reconnect again. Okay, so what do you think is going to show? What display am I going to see?
I'm coming. I think you will not see anything, no, because according to what I learned so far, the index will always start from 0, 0, 1, 2.
No. For this, it doesn't start 1, 2, 3. For this, actually.
Okay, if it doesn't start
I
with
think.
0, then you see Zainab.
Oh no, so sorry. Apologies. It does. It does. I've forgotten. I don't know. So this will show Zainab. It does 0, 0, 1, 2, 3. And I think that was why it was showing me. Oh, I see now. I see now. I see now. Okay, so the I see now. I actually forgot that if it's a tuple, it also works like a tuple. So I did something like this. Apologies. I say return A1 plus A2 plus A3, right? This is what I did. I now said add. I put only 3 arguments there, which was why it was telling me to pull index out of range. Now, what will happen is if I add the next one is going to do the addition for me. And if you do the addition of 3, 4, and 7, apologies for that, I completely forgot. Do you get? And so,
Yes, sir.
like rightly said, it's supposed to start from 0. Or I could just say, so it's supposed to start from 0, like this. That is 1. Then, then, sorry about that. This also works. B plus equal to 8. Return B, it will work. You know why? Oh, so I'm supposed to say B. Oh, oh, it's a tuple. It doesn't support. Okay, so this will not work, but this other one works. Sorry about that. Other one works, and the reason is because the reason why it was showing me that error was because I started from so I said first element, which is second item, third item, fourth item, and I only put 3 arguments. So imagine if I say so this is 0, 1, 2, right? So if I do like this, I'm still going to get an error, and that's because I said 0, 1, 2, and I'm putting only 2 arguments. So if I say, even if I do like a long list of arguments, it's going to only print out, it will only do the addition for the first 3 elements. 13, that is 2 plus 3 plus 8. Sorry about that. I don't know why I don't know how I actually forgot about this. It's really interesting. Any questions so far?
No, sir. I'm okay.
Okay, so the next thing we'll be talking about is have you ever seen these quarks before? Have you
No,
ever
sir.
seen? So this
I
is
think
what they
is a form of the arbitrary statement.
so this is what they call key value argument. The way a dictionary works, and you use double asterisk when you are putting the key value argument. Hopefully, God, this is 3:30 already. Maybe in the next session we're actually going to discuss about that. Then hopefully if we do that, we'll also discuss about classes. I don't want to give, but I think I'll give an assignment here. I'll send the assignment I want to give here
Okay, sir.
so that we can actually play with it. Any questions?
No questions so far, sir.
I want to ask question. You better ask now or you ask later in the group which one.
Currently, I don't have any question. I'm still good with what I learned so far.
Oh, okay. So
Unless if you want to ask question for me.
no, I really don't have
Okay.
any.
All right.
Um, what do I want to say? Just please try and follow up with all the sessions we've done. I'll still send the link again on the W3 schools that we can use.
Okay, sir.
I don't. Did you attempt the first task?
Yeah, like I said yesterday, I was
Okay,
just going through.
you're checking. Okay,
Yes,
please
yes, yes.
attempt share your findings within the week before the next this because I'm about to give you another. So it means that you have like two tasks to actually do this
No
next week.
problem. I'll try to go through them.
So basically we'll be talking about the keyword argument. We'll talk about classes. Um, we'll talk about classes, inheritance. I don't know if we'll talk about polymorphism, but and if we are done with that, I think that will be the end of the Python session. So we'll also talk about um,
What about the object orientation, sir?
the object oriented of programming is basically the use of classes. You get?
Yes, sir.
We'll talk about lambda functions after this as well. The object oriented programming is basically the use of classes.
Okay.
What it means is just the use of classes. We'll talk about that. I will not do anything that has to do with regex, regular expression. I hate regular expression very well. I will also not do anything that has to do with what's the name of this very annoying stuff, recursive function. It's a very annoying function. I don't like using it because if you enter inside trouble, to give you one chance. Then we also use the try.
What if we met it in our day-to-day activities? How do you
Usually,
solve it?
I would advise that you avoid recursive function as much as possible. It works fine, right? But if it doesn't work fine, it works really bad for you.
Okay.
You can just imagine if you are doing a recursive function is basically asking it to do the same thing until it has fulfilled its condition. So imagine if you are unfortunate to give it a function or give it an instruction to do something that it doesn't have any close anywhere to stop. It will continue running until you break it. It's not really. I don't even know why they created recursive function, and it's unfortunately is in most of the programming language. But I don't know why they did that. I'm trying to understand the reason behind that programming, but I really don't know why they did recursive functions. So we'll talk about Sean. Oh, we'll also do file handling as well. Then after that, I think we'll do. So is there anything you are currently studying?
Yeah, actually, I'm studying database modeling, whereby we get some business requirements and try to turn them to um, programming by doing their AR model and then do schema and all those things. So
Oh,
trying
so
to, yeah, exactly.
you have joined the. Are you on the SQL this thing? You're not in the SQL session, right?
I'm not.
There's a SQL session also during the weekend.
Oh,
Yep.
and that one's take by which time, sir?
Today is by 4:30, between 4:30 to 5. If you want to join, I'll be happy to share it immediately as well.
Okay, no problem. I will try to join as well.